Hello, uh, a big Mrs. Doubtfire hello to you. So in an effort to keep myself honest about the work that I'm doing and streaming, I'm getting online here and just gonna stream some work. I haven't been streaming everything I've been doing in this code base, just kind of when I've hit some certain problems where I'm like, oh, that seems like a good point to share with people and just capture it for future knowledge, mainly for myself. Uh, so, uh, just a little bit of background. Last where I left off, I had been importing information into a database. I've been trying to do. I actually built a little query language around the data in that database. That query language is very similar to things that you might see in the OSM space. I think it's called OQL. Uh, I kind of wrote it around the data that I have because it kind of fits pretty well. And but it basically, as you can see, it maps out to a bunch of SQL here, and I've got a lot of test coverage. But where I'm running into issues again is actually data integrity in my SQLite database. Data integrity not necessarily being a bad thing, just more of like I expect more data to be in there, and I'm writing SQL to make sure that that data gets populated. And I should probably write some tests about that just so uh, I can ensure that the data is consistent. So this has been my test for the data integrity. I have a small fixture file here, which is a OSM PBF sample that I pulled off the internet somewhere. I thought I had a link to where I got it from. I'll make sure I capture that here because I don't want to lose that. So one of the things I'm trying to calculate is bounding boxes across the OSM data. So I have node, ways, and relations in my database. Well, nodes have a bounding box because they have a point lat long. Ways can have a bounding box, which is ways are made up of many nodes, and that those nodes, in different points can then have, well, the uppermost, the bounding box to get all the nodes within that, right? I just find bounding boxes easier to work with. The thing that I'm trying to build doesn't need exact data, it just needs good enough data. So if some things are missing or if some things are additional, that's okay. So to build a bounding box, I have, let's dive into this a little. So this builder, which is a very large SQL Go code to, it's a very large Go library that is currently importing all the data from the OSM PBF file into my SQLite database. Last time we did some optimizations and the insert, and now we're doing bounding boxes, which itself has required some optimizations. Mainly just I create this table of the OSM way or relation has a reference to either an OSM type or way, and that way I can use an SQLite database or a table to make the associations. This is just good database building. So, bounding box. My bounding box is these four columns right here, right? So let's put this to the right. Let's make this a little bigger here. Okay, cool. So I want to make an assertion that bounding boxes are being created for ways and relations. I don't know how this data actually looks like right now for the sample PBF. Let's do my favorite thing where I just build it real quick, and then let's take a look at it in SQLite, SCLI. Oh, so I do have code that I've already written for ways in relation. I'm just going to comment this out for a second. so I can show you the issues that I'm having. As you can see, it's pretty fast. Okay, so if we do SQLite 3, test DB, make this a little bigger, what we can see is from entries where OSM type equals node, we can see all nodes have a bounding box. It's just the lat long repeated for both points. So the bounding box is this infinite small box, which is a point. But if I do this for away, there's no bounding boxes, right? We see no lat or long. We don't set that at the moment. But we do have values for the nodes that we can use to build that bounding box. Some of these actually have a bunch of nodes, right? So as I said, these I'm actually inserting into this database table right here because I found working with JSON, though it's easy to work with JSON from a field, it's actually pretty slow. SQLite is a database. It's built to use tables. So I'm putting, even though this is all duplicated data at the moment, I'm putting it into the database table so I can write some SQL queries. Okay, so let's choose this one right here. No, it has no bounding box at the moment. It's a highway paddock, sure, right? Well, yeah, okay. So it's got these two nodes. So let's do a select star from entries where ID equals 330. I just want to clear up everything. Okay. And then we can do where OSM type equals node and OSM ID in, yeah, I can just copy this. 330 is what I got. Yeah, okay. There we go. Okay, cool. So what is our bounding box? Our bounding box would be these four values. This one, this one, this one, and this one. So we can take these values and do a bounding box. Let's bounding. Well, here we'll just do it right here. I'll just use this as a scratch pad real quick. So these points are just from the sample database. I couldn't tell you actually what they're used for or not, but that's all right. So, and let's do mode. Oops, nope. Mode columns, so we can actually see what we're looking at. Okay. So those are lat long. Okay. So our bounding box is going to be the what is the min lat? What is the max lat? Min long and max long. So just out of these numbers, what we can see is our min lat is this because of 765. Our max is going to be this one. Luckily, it's only 2 points, so it makes it really easy for us to figure out these things. So min lon is going to be to this one. Oh, it's a negative number. So the min will actually be the other way around. I know stuff. I know math. Okay, so this is what we're looking at right here. So the reason I have this is because I want to write a SQL query that ensures that this particular way, once this thing is built, and we're making assertions about the data in the database, that it's as expected. So let's do a. This thing only returns a single. Actually, I don't know what's going to happen. What happens if I just do star and then say where ID equals 330. Expect search ID to be something. We're just going to make it a value right now. Eventually it's going to look like something like this, but I don't know what's being returned here. Points. Let's just say points. Tell you what, we'll even be specific. Min, lat, max, lat, min, long, max, long. Don't know how many times I've had to repeat that over the past. Okay, so if I run ginkgo dash watch dash r. Oh no, I gotta do. Can I do tags here? I think I can do tags. Ginkgo supports build tags. Compilers. Tags. Okay, yeah, all right, yeah. I need to do that. Okay, so it's not going to run because I haven't made any changes, blah, blah, blah. We should have a single test change. And it's going to be like, oh, yeah, from entries, right, equals. All right, so we should have a failure. Where ID? It's not updating fast enough. Okay, expected 4 arguments in the scan. Okay, so I can't, my current function here doesn't return enough results. Sorry, I'm just looking at this, trying to think of. I try to keep this pretty generic, but SQL stuff in Go is a pain in the butt. Ruby just made it so easy to be like, here's a map of things. That's what you wanted, right? Yes, of course. Golang SQL scan into map. Can I do that? Yeah, let's do that. This might change a bunch of stuff, though. Well, we'll see. This won't work. Oh, and then it's got some fancy function to do all this. Yeah, let's see. I just wish there was some wrapper that did this. I think SQLX Golang does this for us. Yeah. I think it handles maps. Maps, slices. Yeah. Yeah, support for blah, 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 for batch insertions, but I think it'll work. All right, cool. We're going to use this real quick just for our tests. Perfect. Let us no. Go get blah blah blah. We'll run our test, blah blah blah. We'll do this. That that doesn't work. Think you go. And then we can just do SQLX. And then we can do select. Nope. Yes, I gotta give it a var results equals map string interface. There, we're gonna do that. We're gonna do this. That just returns an error now. So we can do this. And then we can return results. Well, let's make it the right type. This is going to change a lot of... What is it? Does it change stuff around? Let's see how it works. Must pass a pointer. Oh, okay, well, we can do that. Cannot use query a value. Nope. Yeah. Wrong order. So we're trying to expected slice, but got map. Oh, okay. So 1? No. Query row? There we go. Something like that. Scan. Oh. What was it? There's something get. There we go. That's what I'm looking for. They have a command for just a single thing. Unsupported scan. Storing driver value int into map64. Okay. So it does not like that. Can I just make this an array of things? Are we okay with that? Scan error on column index 0. Count unsupported scan. Storing driver value into int64 interface unsupported scan. It does not like an array of things. It just wants. Okay, so this may not do what I thought it did. Which is okay. Okay, yeah, I'll tell you what. What happens if I just give it? Interface. What happens then? 4 columns. Scannable destination type interface with more than 1 column in result. Okay, I'm not going to win here. I don't think I can do this as a generic function. I was really hoping I could do that. Okay. Well, whatever. Let's revert this. Revert. Revert. Come on. Revert. And we're just going to do 1 for... I'm just going to call it SQL4. Bring this back in. Get rid of this. This is... Okay, hold on. That should rename everything below here for us. Okay, so just namespace collision. We're gonna do value 4, blah blah blah. Result interface. Well, so can I just do that then? Size int. Make this. Da, 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 da. Nope, it does not like that. Not enough arguments. That's all right. Let's do that. Expected 4, got not 40. Yeah, I think I run again. There you go. Scan air column index 0 min lat destination not a pointer. Can I just do this? Oh. Any? No. Any. No. There's no clever way to do this. You just gotta. Okay, that's fine. Come on. Use my favorite thing here. Expects item interface. Don't care. Int return item. Oh, and then, well, low has this. Low. Okay, all right. Low does have this. Any to any slice. Okay, perfect. I don't want to write all these things in Go all the time. I'm glad somebody has a useful function for it. Bam. Destination pointer is nil. All right. I got it. It's got to be populated. Doesn't like that because... Man, there's no programmatic way to do this. People are looking at it like, what are you doing? Please stop it. All right, I got it. We'll just be super explicit. Or, what? Let's try one more thing. We got this. Guess what? We're gonna get. We got it. Brain just had that like, oh, why have you been struggling with this? I'm gonna go back to SQLX. go. Gonna go back here. We're gonna get. We're gonna do result any, and then we're gonna do any results error error. We don't return anything. I see it finally now. I see it. And then we're just gonna do this. Int result. Var int result equals int 64, and then we're just gonna do this. Do that. Then we should be able to take all these. Boom, 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 boom. Pass it in. Now, these are just going to be var search ID and way ID as int 64s. Sometimes you just gotta work through a problem to understand how to solve it. See, and this isn't that bad. What are these complaining about? Not enough arguments in client get. Did I do it backwards? No. Not. Oh, no. Just up way too high there. Okay. Okay. So now, value. My point, which is a struct long, max long, float 64, and then I should be able to pass this in as points. Oh, points, and destination type struct with 4 columns, destination type struct with 4 in result. Yeah. Scannable destination struct with greater than 1 columns, 4 in result. Yeah. That's right. Hold on, I'm gonna be right back. as you're probably seeing, this is a lot of work to write a test. This means it's worth it. So the last thing that we had was a scannable destination type struct with greater than one columns, 4 in result. So let's look at the SQLX examples. Forget. It has a person. A person is a place string. No? Is it just because I have this written? Oh. Is it because of this? They're not exported. Missing destination name. Okay. Got it. It does not like these to be the way they're named. Whatever. We got it. I think this is just a product of having different naming conventions across different programming languages. And missing destination max. Oh. Converting null to... Okay, is there an SQL null float64? All right. Come on. These shouldn't be null later, but they are at the moment. Mainly because they aren't the values that we've calculated yet. So they're null because I don't want anything to be 0 for a bounding box unless it needs to be, right? So, okay, so now we can actually make some assertions. I bet you're like, finally. All right, so let's just do this. Let's make an assertion that says min lat dot valid to be true. We're gonna do this the whole gamut. Let's just cover everything. All right. And then let's do this and say, is it just value? Value. No. Float64. To be equivalent to, okay, so our min lat, our max lat, our min lon. This is a lot of work in the making here, but it is worth it. Okay, so we do have failing test still. Okay, cool. So if I uncomment that code that I had, and specifically just for the code doing ways, because this is all just for ways at the moment, but hopefully now that we have enough information, we can do it for relations too. Yeah, that's what I was worried about. Might have to change some of these to be numerically there's a matcher for this. Omega matchers. Omega is a matcher. Yeah, I mean, yes. close to be numer. Yeah, I kind of want that, but I want it in like there's one for like a threshold or something like. Matchers for truciness, presence, working with values, working with numbers. Should be numerically equivalent. Threshold. Okay, you can use that. Threshold. Okay, cool. So you do close to this value and then some threshold. By default threshold. Oh, can I just do that? Hey! Close enough. Great. Test pass. And based on our own math, it worked. Tell you what, we'll go back here and get the two nodes that these represent. Napkin math for bounding box. You know, to be honest, our relation's probably going to be that much harder to do by hand. I'm going to assume it works. But this is working. The logic for a relation doesn't change that much, except that it's looking for something that can be a way or a node explicitly. And then we clean up after ourselves because we don't need that table anymore. Great. I love this. Okay, we're gonna just get out of here. So task. Let's see what we need to clean up here. Ooh. I basically have Golang saying any of the complexity and functions and stuff. Just ignore for now. So fun. Here, I'll show you for a second. Anything related to just measuring the complexity of a function, I just commented out because, to be honest, I haven't gotten to my refactoring stage. I've just been more like pumping out features. Great. Let's do a go mod tidy here. Because I'm messing with some things here. Yeah, okay, great. Add support for bounding boxes on ways and relations. So, if we do this, oops, let's do it on a bigger data set. We can see what we got. We got downloads. We got the data for Colorado. So, speed of it, the speed of the import hasn't really changed that much. It just adds another level of calculating the bounding boxes. But I just want to run this on a bigger data set. It's 259 megabytes, just to see that it works. The query language. I was going to show that for a second. Oh, I did. It's the one that looks very similar to OQL. I'm just not going to expose the secrets of how I solved the problem. That's for another live stream. I am totally stalling until this is done. The anticipation of actually having written all these things so that now they have bounding boxes in the data. So the plan is to use these bounding boxes eventually for displaying information on a map and just showing where things overlap and such. So we're doing these calculations for the benefit of that feature. I've started working on it a little, trying to find a good pattern of doing Go web development with JavaScript. Not saying that there's no way to do it. I'm just saying that, I don't know. I still haven't found something where the kind of live reload cycle that I'm used to in other languages, Ruby and JavaScript for the backend, exists with Go. You know, I have to like stop it, restart it, especially when I'm doing things like Go generate to generate templates and such. I'll find it. Then I'll report it back here. Oh, look, the import slowed down there a little. How's our memory usage? 400 megabytes. I am okay with that. My early experiments of doing optimizations had that thing loading up into like the 20 gigabytes with swap and everything. So the fact that we got it down here, and if it sacrifices a little speed there while inserting, I am okay with that. I'd rather have something consistent and well tested and optimized rather than overly optimized, where that's what I was doing before. So we can see it's doing the bounding boxes. Since all this is wrapped up in one transaction here, where it's creating indexes, doing the insert, or the updates with the bounding boxes. We don't get the granularity of how long each one's taking. But I want to just monitor the memory usage here for a second. I mean, we should see CPU. SQLite only uses one CPU at a time. It's not multi-threaded. Fine. It is still impressively fast. I'm just holding out because I actually want to show, just exploring the data to show that everything has a bounding box on a very much larger data set. I believe this should just take up 2 minutes, so I'm stalling. But I think I'm stalling enough. Tell you what, I'll be right back, and when this is done, I'll come back. Okay, finished up here. As we can see that the import took just under 3 minutes. The bounding boxes took 221, 220 right there. So not that long. I'm always impressed how fast the full text search index is. All right, so let's load up SQLite. So let's load up. Do I actually just have a couple of these right here? Yeah, so bounding boxes. We see bounding boxes, and they're all different shapes and sizes, and perfect. Data's there. Let's do it for a relation real quick. Bounding box. Great. How big is that last database file there? 3.3 gigs. Everything is good. All right. Well, thanks for joining me tonight. I gotta get used to this. Remember to like and subscribe. Just click the buttons in below. Does anyone actually say that anymore, or is everyone just used to it? Cool. Thanks.